Right, hi guys, welcome to the first BTEC Sports screencast of the year. And this screencast is going to be on Unit 1, Anatomy and Physiology. So, this unit is externally assessed via exam. Now, it's the first time that the BTECs have had exams, so it's going to be quite a lot to cover with a short amount of time, and this is why we're doing screencasts, and it'll all become clearer throughout this process. So first of all, what I want to talk about is how lessons are going to be run, okay? So this is going to be every single lesson we're going to be doing this type of view here. First of all, the anatomy and physiology unit, you're going to be covering the skeletal system, the muscular system, respiratory system, cardiovascular system, and the energy system. Now, this word here, flip learning, you may have heard of it, you may hear about it within different lessons that you're taking, but what you're going to have to be doing is preparing for lessons. Before every single lesson, you'll have to complete note on a screencast. That'll only be between 5 and 10 minutes, so we're not asking too much of you, okay? And when you're making notes, you're going to be making Cornell notes. Now, once again, on the next slide, I'll show you what Cornell notes are, but they're a really good way to kind of rehearse and improve your memory when it comes to learning. You're going to come into the lesson and you're going to be doing cooperative learning strategies. You're going to be working with each other to embed the flip learning you do at home. So you're not going to be listening to me talking over and over again in lesson. You're going to be discussing things with each other and working together. Then finally at the end you're going to do homework, which is going to be a 5-minute task, which is going to be emailed to me. It's going to be emailed at the end of that day. The reason for this, research says that if something is rehearsed 12 hours after learning it, you've got an 80% chance of remembering it. Now, that's vital in my opinion. If it comes to taking exams, you're going to have an 80% chance of remembering something over not remembering it at all. And that's why we ask you to do that the night of. But once again, it's going to be a 5-minute email. We're not going to be asking you to read loads, do half an hour worth of work. It's going to be 5 minutes. Right, okay, so what we're going to do in today's lesson is we're going to learn the types of bone. Now, this is what you're going to be expected to do at home. This is an example screencast, but we're just going to do it in lesson today. So I'm with you so you can understand what is expected. There's 5 main types of bone. These are long bones, short bones, flat bones, irregular bones, and sesamoid bones. Now, this piece of paper, this image here, are Cornell notes. This is one that I did for this just to show you. So what I want you to do now is pause this and copy out what I've done here. So if you pause now. Right, okay. So this part here, key questions, you're going to create your own question relating to the side opposite. So long bones, you're going to have in here loads of information put in about long bones. Then you're going to create a question that is hopefully going to make you remember that. And then you're going to do one for short bones, flat bones, irregular bones, and sesamoid bones. As we go through this PowerPoint, you'll know which information you're going to need. An example that I have done for you though is long bones. Which bones are found in the limbs with a shaft, a diaphysis, and 2 ends, epiphysis? Now that become more clear when we go on through long bones. So in this section now, I want you to write this. So these bones are found in the limbs. They have a shaft known as a diaphysis and 2 ends known as epiphyses. Examples are your femur, humerus, your tibia, which is your shin bone, radius, and your ulna. So if you write that in that section, long bones. Also what I want you to put in there is a function of a long bone. So the function of long bones are movement, support, and red blood cell production. Okay, short bones. These are small, light, strong, cube-shaped bones that are compact bones. Your examples are your carpals, which are your hand bones, and your tarsals, which are your feet. So notice carpals, tarsals. The functions of short bones are small, fine movements, i.e. handwriting. Shock absorption. So for your feet, we're walking all the time, they're going to create some sort of shock absorption. If you fall over onto an outstretched hand, it's going to have some shock absorption there. Stability and weight bearing, once again, your tarsals. So the function is to help with weight bearing, stability, shock absorption, and small, fine movements. Next one, flat bones. These are thin, flattened and slightly curved with a large surface area. Examples are your scapula, which you may know as your shoulder blade, your sternum, which you may know as your breastbone, and your cranium, which is obviously your skull. Now we need to know them as scapula, sternum and cranium for the exam. And the function of the flat bones are attachment for muscles and protection. So protection, obviously protecting the heart and the lungs, here as well, the lungs, the heart as well, and quite clearly the brain. Right, irregular bones. These are complex shapes and fit none of the categories that have just been mentioned. Example of these bones is the spinal column. So down here. Now as you can see by this lumbar vertebrae, that is quite an irregular shape. So an example of an irregular bone is the lumbar vertebrae. And the function is protection and movement. So it protects the spinal cord. That's what is protection there, and it helps with movement as well. Okay, so the sesamoid bone, this is a special function usually found within a tendon. An example you need to know is the patella. It's just that round bone there. And as you can see from this here, this is the tendon found running through that patella there, that sesamoid bone. And again, its function is protection and reduction of friction across a joint. So it reduces the friction across the knee joint. Okay, so that's the sesamoid bone. So if you get your notes down, that'd be good. Thank you. Cheers.